protons. And my proton is a nice little pink bead. See? And the electron is going to be my nice little yellow bead. Okay? Ubiquinol, or ubiquinone, is a bottle cap. And cytochrome C is a diet bottle cap. Okay? Does that make sense? We got the key in place here? Okay, so here is our membrane. I was hoping I could have both of these on. No. Okay. So here's our membrane, and there's complex 3. Okay, so cytochrome C is not in the membrane. It's up above the it circles in the intermembrane space. It's aqueous. Ubiquinol, however, is in the membrane. It's membrane embedded because it's got that long hydrophobic chain at the end of it. Remember we showed the picture of ubiquinol? And so what we have is what we call the Q pool. Well, we just got a bunch of ubiquinol molecules that are embedded inside of the membrane. And a bunch of cytochrome C that circles around outside. And one of the cytochrome C is bound to complex 3. One of the ubiquinone is in here. And this is a ubiquitin binding site that's free, right? Okay, so how many electrons does ubiquinone carry? 2? 2, right? So the electrons are the yellow ones, right? So let's say half of the ubiquinone are reduced. Now remember, the thing about ubiquinone is that when the electrons reduce it, they're matched with what? Protons, right? So there's 2 protons on ubiquinol as opposed to ubiquinone. So that the electrons that reduce the ubiquinone are matched with protons. So proton, I guess, I decided to do protons in pink so that it would be phonetic. Protons are pink. Okay, so in every reduced ubiquinone, there's 2 electrons and 2 protons, right? We got protons that are around the matrix space. We got protons up in the intermembrane space. Now, what about cytochrome C? How many electrons does cytochrome C carry? 1, right? It carries 1 electron, and that electron is not matched with the proton. It's just the electron is in cytochrome C, so it doesn't have to be matched. Okay. So the stage is set. Okay. So this again is our Q pool, right? There's ubiquinone in the mitochondrial membrane. Not all of the ubiquinone is oxidized, not all of it is reduced, right? So if I went back to that diagram that we had, where we had the electrons coming in from NADH and FADH2, those electrons are being transferred to ubiquinone in the ubiquinone pool. So there's always ubiquinone floating around in the mitochondrial inner membrane. And some of it is being reduced by it, and others is oxidized, waiting to be reduced, right? So you have this pool of ubiquinone. Okay, so the first step is one of these reduced ubiquinone, the ubiquinol, bind to complex 3, right? the protons leave the ubiquinone, or ubiquinol, and are deposited out into the intermembrane space. So now remember in complex 1 or complex 2, those protons were taken up from the matrix. And they're deposited now in the intermembrane space. So we've had protons translocated just by the Q pool. The electrons, one electron goes up to cytochrome C. The second electron goes down here to this oxidized quinone that's bound to complex 3. Right? So now this is oxidized again, and it goes back into the Q pool. Now, a second reduced quinol can bind to complex 3 in that binding site. And the same thing happens again. The electrons get translocated up into the intermembrane space. This cytochrome C detaches, and an oxidized cytochrome C binds. One of those electrons goes up to that cytochrome C. One of the electrons comes down to this ubiquinol. To match the reduced electrons that that ubiquinol has taken up, protons come from the intermembrane space, and this is now a fully reduced ubiquinol. It gets released into the quinone pool, and an oxidized quinone comes back and takes its place. Okay? So now, how many reduced quinone did we start with? 3. How many do we have now? 2. How many reduced cytochrome C did we start with? 1. How many do we have now?
3.
Right? So we've taken one ubiquinol, taken its protons to the intermembrane space, and transferred its electrons to 2 cytochrome C. That is the cycling. That is the Q cycle. So there's 2 steps to the cycle. Step 1 puts those electrons into cytochrome C and 1 electron into the quinone. The second step fills that quinone and does another cytochrome C. And then it all goes back into the quinone pool, so that the net change in that quinone pool is the oxidation of 1 quinone. So it's a net change we're looking at with the 2-step cycle. Can we do it again?
Mm-hmm.
Okay. So remember that you had 2 protons that were down here. And a reduced quinone that was, so we have 3 reduced quinone, 3 oxidized quinone in the quinone pool. Step 1, reduced quinone binds, protons leave, 1 electron goes to cytochrome C, 1 electron goes to the oxidized quinone. Cytochrome C detaches, an oxidized cytochrome C takes its place. The oxidized quinone goes back to the quinone pool. A second reduced quinone binds, same thing. Protons get translocated. 1 electron goes to that cytochrome C, it detaches, an oxidized one binds. The second electron comes down here, fills that quinone, and to balance those electrons, the quinone pulls 2 protons from the matrix. It detaches back into the quinone pool along with the oxidized quinone, and 1 oxidized quinone comes back in here, and we've started again. We've done a complete cycle. So there's 2 steps. The net change is 1 quinone has been oxidized, and 2 cytochrome C have been reduced. So it's a 2-step cycle that involves actually 3 quinone but the net change is the oxidation of 1.0 and the reduction of 2 cytochrome C. And 4 protons get deposited in the intermembrane space, right? So that's one of the tricky parts, is that 2 protons are in each reduced ubiquitin. But the transfer of the electrons from the ubiquitin to the cytochrome C actually deposits 4 protons across the membrane, 2 from the ubiquitin and 2 from the Q process.